Hey, hello everyone. Good morning. Hope I'm loud and clear. In case you have any questions, please put it in Q&A sections, question section, and then I'll answer those questions. Okay. Okay, it's already 11:05. We'll start today's session. So today we are going to discuss about Azure Data Services, which is again part of module first, which comprises 20 to 25%. Uh, okay, but before that, uh, we'll just go to our previous topic, which was about different roles in big data world, right? I'll launch one poll, so please fill in that so that I get an idea which role you are aspiring for. Okay, we'll give you 10 more seconds, guys. Fill it as soon as possible. Okay, it's already 1 minute. I'll end this poll. Okay. Okay, so most of you guys are targeting for data engineer. So I got your point. So we will focus on that. And also, it doesn't mean that we'll ignore the other roles as well. But this is very fundamental discussions about different roles in the world of data. And this course mainly focus on data fundamentals, which is for each and every role. It's very, very important, right? Whether you are aspiring for data engineering, whether you are aspiring for data analysis, whether you are aspiring for uh, data scientist role. So again, it's going to benefit you all irrespective of the roles you are targeting. Okay, let's start with today's session, which will start with the data services being offered by Azure. So there are multiple data services being offered by Azure, and all are important, right? And it depends on the requirement of the organization whether they would like to use all of the services offered by Azure or they would like to use some of the services. So let's say in case uh, I think each and every organization will always work with relational database systems. Okay, so in that case, Azure SQL obviously they are going to use Azure database for open source in case they are already using MySQL or other open source database and they want to migrate their systems or infrastructure to cloud, then definitely they are going to migrate to Azure database for open source just to take advantage of cloud infrastructure. Then we'll talk about Azure Cosmos DB, which is basically a NoSQL database, which comprises all the four kinds of NoSQL or non-relational database that we learned yesterday. So, do you remember the four different kinds of NoSQL DB? It's key value, documents, right? And then graph DB, we have columnar family. So these are basically four different kinds of NoSQL DB. Then we'll learn about Azure storage, what are different offerings under storage part. It's Blob and Data Lake Gen 2. So all those will cover in Azure storage. So right now we will go through each and every services which is being offered by Azure in terms of data, right? So we are going to go through different data services. I'm not going to cover all the services of Azure, but it's more of data related services, which is uh, basically required for data engineers or data scientists or data analysts or data administrators, right? So we are going to focus on these different topics today. Okay, so what is SQL? In this case, we have one service being offered by Azure, which is Azure SQL, and it's its collective name, right? So in case you see Azure SQL anywhere, then it means that there are three different kinds of offerings we have in Azure or being offered by Microsoft Azure. One is Azure SQL database, another one is SQL managed instance, and the third one is SQL VM, which is basically virtual machine. So what's the difference? Azure SQL database, as the name itself says, it offers database, right? It's a fully managed platform as a service, which is PaaS, and it will offer you database to be used by your systems or to be used by your organizations, and that will be hosted in Azure infrastructure. So in case you have any requirement or you are trying to make use of Claude, or you are new to Claude and you want to create new database for your applications or new application, then in that case definitely you are going to use as Azure SQL database. Then we have Azure SQL managed instance. So again, it's SQL. It's similar to SQL database, but apart from that, you have certain flexibility in terms of configuration, which you don't get in Azure SQL database. So with this, in case you want to modify certain configuration details in the Azure SQL databases, then you definitely want to use SQL managed instance. Otherwise, there is no difference. There is not much difference between this Azure SQL database and Azure SQL managed instance. And whenever you see that you want to configure or change the configurations, right? In that case, you will have the responsibility of managing those configurations, right? So in case you want to manage those configurations, you want to take care of the administrative task, then definitely that will allow you certain controls on the configuration part as well. So if your requirement is to control certain aspects of the configuration of SQL Server, then definitely you want to go with SQL managed instance. So that's the difference. In case you just want to use database, SQL database, you go with Azure SQL database. And in case you want to have certain controls in terms of the configurations, then you should go with SQL managed instance. What's Azure SQL VM? As the name itself suggests, it's a combination of SQL plus VM. So along with SQL database, you get virtual machine. So in this case, you have responsibility of managing a virtual machine as well. So this is most suitable when your organization is already using SQL Server and you want to just lift and shift. You don't want to change any configuration. You don't uh, uh, want to you just want to make efforts or to migrate the existing SQL database, and then you should have certain controls in terms of configurations, as well as the another layer. We are adding another layer, right, which is virtual machine. So in this case, you will have to take care of virtual machine as well, whatever the configurations part or maintenance part of virtual machines, then definitely you should go ahead with this if you want to take control of virtual machine, because in the previous two instances, like SQL managed instance and SQL database, you don't have control of machine, virtual machine. So in case uh, you want to control the configurations of the OS operating system, then you should definitely go ahead with SQL virtual machine. That means it allows you certain configuration, but additionally you will have to manage those infrastructure part or virtual machines configurations and all. Guys, if you have any questions, just put it in question section. I'll take it from there. Okay, now we are going to see different offerings of Azure database for open source relational database. So it basically focuses on three different open source systems. One is MySQL, another one is MariaDB, and then the third one is PostgreSQL. So most of the organizations these days use these three open source relational database only, and hence Microsoft offers services, data services mainly for organizations which are using MySQL or MariaDB or PostgreSQL, and they would like to move on-premises infrastructure. They would like to move on-premises this open source relational database to cloud. Then for that purpose, they are offering this Azure services for this open source relational databases. MySQL. In terms of MySQL, again, it will it's open source, right? All of these databases are open source systems. So we just need to understand in brief what are the offerings. So for MySQL, it offers the same capability that you have that you get in open source system MySQL. So it's very much similar, but the services that they offering is uh, that's comprised of community edition. So in each and every open source, you always get a community edition. Apart from that, you get standard edition or express editions like that. But for that express or standard or premium editions, you need to pay a certain amount, and they just take care of support. They provide support in case of any issues with implementing this MySQL or MariaDB or PostgreSQL. So in this case, when you migrate to Azure, you always get support from Microsoft for these different databases. And the plus point is you get access to many different other offerings from Azure, and you get access to latest tools and technologies. And most of the organizations are moving towards cloud so that they can innovate and they can adapt to the market changes because these days technologies are progressing or changing each and every day, right? So in case you want to be in the race, then that's one of the reason that most of the organizations are moving to cloud so that they can utilize latest tools and technologies in the market. And then the third one is Azure database for PostgreSQL, which is all of these offerings are similar, right? So PostgreSQL is we already saw it's a hybrid and it offers certain customizations in terms of data types. So you have option to create custom data type as well. That's one of the plus point of PostgreSQL. And it also works on non-relational databases, right? So it support offers for relational as well as non-relational. It's kind of a hybrid database systems. MariaDB, it's again one of the open source. This is basically created by MySQL developers as well. It has been optimized and it is compatible with Oracle database systems. So most of the organizations also use Oracle in case they are working on relational database. And hence this is one of the open source. In case your organization is using Oracle and you want to move to open source systems, then MariaDB is one of the choice for you. You can move because it offers the compatibility with Oracle database. Okay. And now we are going to see the benefits of using Azure Cosmos DB. What does it comprise? So it basically supports non-SQL database systems. Okay, and non-SQL, and in order to support non-SQL database systems, as we learned in our previous session, there are four different kinds of non-relational databases. So in order to support all those different databases, we need some kind of API, right? Because if you have a single tool to offer the services of all different kinds of non-relational database, then there should be some way using which you can say that I want to make use of key value store or I want to make use of document DB. In that sense, you need certain syntax or you need certain tools or you need certain kind of interface, right? So in this case, this Azure Cosmos DB provides APIs so that in case you want to work with document database, you use the document database API. In case you want to work with key value pairs database, then you just access this key value pair database using the different APIs. So using different APIs offered by Cosmos DB, you can connect to different non-relational databases. So it all depends on the requirement. In case you are working on key value pair database, you will use key value APIs. Okay, that's all basic description of Cosmos DB. Now we'll look at Azure storage. These are all in brief, and we are going to cover this in detail in the coming sessions. This is what we need to know, and it is as per the syllabus of DP900 itself. And you will understand the basics of Azure and Azure data services. So don't worry, guys. We are going to discuss or see this in details. For now, we just need to understand what are different data services offered by Azure. So as the name suggests, it's Azure storage, right? So it is something which is beneficial for storage purpose. Right? So you have when you work in big data world or when you work with data, you always need storage, right? So storage in the sense you want to store the file and then later on when it moves in the data pipeline, then you process the data and then again you save it back to certain kind of storage systems, right? So for that purpose, Microsoft Azure is providing different services. One is blob containers, which basically is stores binary files, blobs. Blobs we see binary large object, which is whenever we talk about blobs, you just understand that it is for storing video or audio or large objects, right? So they're just keeping mind you don't get confused. Blob means you just related with audio, video files or certain large objects files. Then we have file shares. So if you are already working in any organization, then you must be working with network shares as well. Or even if you're in college, you might be sharing your local folder with other guys within your network using file share, right? So it's kind of a network file share that is provided in Azure, and it can be shared across different departments uh, in your organization. So for that purpose, in cloud also we have certain option to create a network file share, and which is basically we call it file share in Azure. And then we have tables. Okay, this table is nothing but a key value storage, and here don't get confused because this is not the normal table that we see in database systems, right? This is different from that. It is as we are discussing the storage part here, so you just understand that it is something similar to a file systems or network storage, right? It will be similar. Don't get confused with tables. It is not a DB table. It is different from that. So we are going to see the structure. How do we create or store this Azure tables? So basically, it has got key and value. So you will see key and you will see rows and columns, but we store that within a storage system, within a file system, and you won't have option to run uh, uh, you don't have option for whatever you get in relational DB systems, right? So all those options, those relationships and all, you won't get it here. So it is different from that. We are going to see in the upcoming slides. And next we will discuss about Azure Data Factory. This is very important if you are working in Azure or in cloud, right? So this is basically used for processing part, right? So in case you have you already have data and you want to basically transform it or apply certain transformations or ETL processes, then this is go-to tool. So you want to utilize Data Factory to get to basically create data pipelines, get the data from different sources. So which is the first part, data ingestion, and then You transform it based on certain logic. So you create different activities for the transformations. So the main idea behind data factory is to build a pipeline to right from data ingestion, getting the data from different sources, which we call the upstream systems, and then you do some kind of transformations on it based on the requirements, and then again you store it in some data stores, right? So all this can be taken care using data factory. Okay. And next we're going to see Azure Synapse Analytics. What are the different options we have in Azure Synapse Analytics? So Synapse Analytics is a comprehensive unified platform, and it's also most widely used in Azure systems whenever you work with uh, big data, right? So it's a unified platform where you get different options for data analytics. It's a single interface. You don't need to separately create data pipelines, or you need to create uh, Azure SQL, or again you will create services for Apache Spark. No, it's a unified platform wherein once you create Azure Synapse Analytics service, you will get option to create data pipelines, which you get in Azure Data Factory, and you have option of creating SQL database as well and within Synapse Analytics, so that you can work on data warehouse. And then you also get option of you get this Apache Spark as well for distributed data processing, which is basically most widely used framework these days in most of the organizations, in case you're working with large data sets and big data systems, right? So this is uh, I think old organizations were using this Apache Hadoop, uh, which is MapReduce basically for the processing purpose, but people are migrating towards Spark because it offers more flexibility, and it's also friendly to the developers. You don't need to spend time to learn different MapReduce syntax and commands and all, which is a bit complex. And apart from that, it is very efficient in processing big data or large files. And then it also contains Azure Data Explorer. So it offers high performance analytics solution, right? Uh, which basically deals with the logs or telemetry data. And you have option to use KQL, which is nothing but custom query language. Okay, so you can query these log files using SQL kind of language, if you want to fetch any information from the log files or telemetry process, then you can definitely use Synapse Data Explorer. And then we have Azure Databricks, right? So whenever you talk about Spark, so most of the systems are on Databricks. So we get if you talk about Azure Databricks, it's again combination of Azure plus Databricks. Databricks is a different company that offers services for Spark, and Azure is a different company, right? So this is an integrated platform wherein you get option to implement Databricks, to use Databricks in Azure. So this is a Microsoft version of a Databricks platform. And the main advantage of using Databricks, in case you want to migrate or move to different clouds, then we have Databricks offers services for different clouds as well. You get options to use Databricks in Azure, you get option to use Databricks in AWS, you get options to use Azure, you get options to use Databricks in GCP. So it provides you flexibility or options to perform big data analysis or transformations, or those uh, optimizations on the data part, right? So you have option to use SQL and run SQL queries on top of the data, or else you can work with different uh, you can create basically you create a notebook in Databricks, and then you work on transformations part, writing your code in Python or the other language. And then we will talk about Azure ST Insight. So these services mainly focus on the open source systems, right? So there are open source big data processing systems or the technologies in today's world, which is very popular. So as we already saw about Spark, Apache Spark, which is a distributed data processing systems, and which has got option to create. You can book, or you can use different languages like Scala, Python, Java, or SQL and work on data. And then we have Apache Hadoop, which is basically provides a platform which is a file system, as well as it also provides you uh, tools to use data transformations and process large data sets, which is basically you create a map reduce job and then you process large files. And then Apache HBase, it's again an open source, which is basically NoSQL databases. It has got storage, and then you can run kind of SQL queries on top of that. So we don't call it SQL. It is basically NoSQL, right? So it's a kind of non-relational database systems in open source world. And then we have Apache Kafka, which is basically a message broker, or you can understand it as you create a queue wherein you get data in different streams. It's basically you get continuous streams of data, and then it comes and gets saved, or it stores in MQ message queue, and then you process the data based on as soon as they reach in the queue, and then we take it from there and then process the same. So this is basically used for streaming purpose or data streaming. So these all are open source systems. So what Azure or Microsoft has done is they have combined all these frameworks or technologies into a single platform. So they have created ST Insight that comprises Apache Spark, Hadoop, HBase, and Kafka. In case you have um, requirement to use or requirement to create or work with open source systems, then you can go ahead and create ST Insight services that will allow you access to Spark, Hadoop, HBase, and as well as Kafka. And then, so basically we have covered for batch processing, right? So this is one of the services that is being offered by Azure for stream analytics, right? So in this case, if your requirement is to work with streaming data and then you want to generate insights in real time or near real time, then this is one of the offering from Azure, which is basically you can work on streaming data, and which provides an input stream similar to what we get in Kafka. So you get data on continuous basis, store it somewhere, and then you take it from there, you process as soon as it receives in the queue, and then you write the result to kind of output, some different output, or you store it in data lake, or you store it in data warehouse based on the requirement. And then we have Data Explorer. So Data Explorer is part of Synapse as well, but this is a standalone service, uh, which is basically the same as what we see in Azure Synapse Data Platform. So you can query log files and telemetry data using KQL language, which is custom query language. So it's basically the same that we get to use in Azure Synapse Data Explorer. And then we have Azure Purview, right? So whenever you work with large data sets, or whenever you work with any kind of data, right? So you need certain systems so that you can apply governance policies. You can apply certain rules on top of that, like who all will be able to see the data or have access to apply certain transformations or have access to sensitive data or confidential data, right? You may have certain data which may be public, so you don't need to care about. But in case you have certain sensitive data which you don't want to share it with all of your guys or within organization, then you always want to use such a tool which can allow you to set different permissions, a different level of permissions for different roles or different groups. So for that purpose, we have Azure Purview. What it does is you get access to data governance tools. So you can see data lineage as well for any source. So what is data lineage? So in data lineage, it's kind of a graph that it will show you, or a flow chart that you see, right? You can understand in simple terms. It will show you right from where data originated, how it got transformed, and where we save this data. So all this entire picture, you'll get the entire picture in data lineage. So you can use that functionality to track any data changes or track any issues. And then the final offering is Azure Fabric, which is one of the new offerings from Azure, and it basically comprises all the tools and technologies. So whatever we saw right now, let's say ETL technologies or data lake horse or whatever, right? Or Synapse Analytics, data visualizations like BI, Microsoft BI, or Spark, uh, database, everything, right? So everything is under a single umbrella, or everything is under a single service, and they have combined all those in Azure Fabric, which basically offers uh, one platform so that you don't need to create different services. You just create Azure Fabric and you will be able to utilize all these functionalities right from storage to visualization and data governance as well, which is basically part of Microsoft Purview. So all those functionalities you'll get it in Azure Fabric. So that's end of part one, which is module one, which comprises 20 to 25% of DP900 Azure Data Fundamentals. And now we are going to see the second part. We will start the second part of it and see what all do we need to cover. So in this second part, we'll discuss about relational data in on Azure. So any questions, guys? I'll wait for a minute and see if you have any questions. In case you have any questions, put it in questions tab. We'll also see the labs. So in the first module, we don't have any labs. And from the second module, we'll see exercises. There are multiple exercises. So we'll go and create uh, different services, and we'll see how we create a service in Azure. So one of the questions from someone is like, do we only study the theory part, or we will have lab exercise as well? So just to clarify, we'll have uh, labs as well, exercises as well. We are going to cover all those. Any other questions? So in the first module, we basically see what are different offerings from Azure side, right? So we don't want to overwhelm. So in case we start working or creating services, then people might get overwhelmed, right? So the first module is always about understanding the concept, basic concepts and different offerings in data field. So we have covered all the offerings of offerings related to data services in Azure, and now we'll go a bit in detail and we'll discuss relational data systems, we'll relational, non-relationals, we'll see uh, data visualizations or other part in the upcoming modules. Okay, I don't see any other questions. We'll start with the relational data. So in this module, so we are going to start this second, right? So second module comprises core data concepts, and we are also going to see different roles and services, different services that it offers. So services means we are going to discuss about SQL services, right? So in the data concept, we are going to cover relational data. We are going to understand normalization. What is normalization for a database system? We are going to explore SQL. We are going to understand different objects, database objects, and then we'll see different services, Azure services, in terms of relational database systems. So we'll talk about different Azure SQL service and its capabilities. We'll talk about open source databases, and then we will have exercise, right? So you see now we will cover exercise as well, explore Azure relational databases. And in case we are not able to cover it today, definitely will share you uh, the link using which you can do exercises, because anyway you'll have to create your account in Azure, and then using your own account you will be able to create different services. But definitely we are going to cover it. If time allows, we'll cover it today. Otherwise, we'll take it up in our next session. Okay, so we are going to discuss relational data in Azure. So first of all, we'll have to understand uh, what was the issue with the previous uh, systems, right? Or the previous computing systems, or was there anything similar to database systems that we are using these days, like relational databases or non-relational? Uh, so in early days of computing, right? So the problem was each and every organization, or let's say each and every individual, if they work on storing the data, right? If they have a requirement to store the data, then they create a separate framework, they create a separate structure in order to store even a simple data. So it was very difficult for other developers, because they had to learn in what way it was created, in what's the framework, what's the format, and how it was developed. So they had to understand everything right from scratch, right? So that was one of the disadvantages, because each and every organization will have different framework. Each and every organization will develop or store data in their own format. And if a new developers comes in, or if anyone comes in, they had to learn it from scratch, because they were not aware of in what format the data is being stored, what how was it developed, and what's the command, what's the syntax, all those part, right? So it was a major challenge for the organizations, and hence there was a need of a common format, or there was a need of a common systems to store data or to work with data, or any uh, uh, data model, right? So in that sense, they work together and then come up with certain relational database systems. So this was basically designed to solve this problem, because earlier most of the organizations were using their own different framework or different uh, structure to store the data. So relational database basically solves that problem, and then we are going to see what all is being covered as part of relational database, and how do we create a model, how do we query data. So we are going to see all those. So what's the key advantage of creating a relational database systems, or creating a relational database or data model? So the main advantage is it's the use of table, right? So we store data in forms of rows and columns. So if you work with CSV file, or if you work with any data files, relational database files, even if you open any Excel sheet, that will have rows and columns, right? So it's very easy to understand. You can see different rows, you can understand uh, different columns, its meanings and all, right? It's very efficient and intuitive as well. And you can store data uh, without much hassle. So it provides certain steps so that you are able to store data without any difficulty. And also the structure, right? So it's kind of structured information. So we learned about different data formats, right? Which is basically structured data, unstructured data, and semi-structured data. So relational database systems mainly manage structured data. So in case we have requirement to store structured data, we'll definitely use relational database systems. And also for semi-structured data also, after certain processing, we can definitely store it in relational database systems as well. So this is how it looks like, right? So you store data in form of table, right? So you have let's say you're working with different entities, and we are talking about uh, retail management system. So in this case, retail management system, right? You will have customers, you will have product, and then customer will order certain uh, products, whether he or she is on ordering online, or it may be in offline mode. But the thing is, you will have these different entities, right? You will have customers, product, order, and then different line item. Line item is different items that you have ordered, different products that you have ordered, what's the quantity of those. So all those things are getting stored in different uh, tables, database tables, right? So it's a format for structured data. So whenever we want to store any structured data, then this is the way how we store it in a relational data database systems. We create different tables. So the first part is obviously you'll have to create a database, and then you are going to create tables. And using SQL, you can insert data in the tables, and you can store all those required data, or you can integrate it with the applications, and whenever the transactions happen, it will automatically update it in database systems. So this is one of the example of relational database systems. How do we store data in relational database? And one thing to note down here is each and every row will have same set of columns, right? So it doesn't happen that the first row is having different columns, the second row is having different columns. All will have same set of columns, and it the column represents a single data type, right? So you won't be able to store, let's say, first name. It's not float or number, or so, right? It is a string, or basically the characters, right? So it's only one specific data type that you tag a column, right? A column can only have one data type. Though you have option to create in certain relational database systems, you have option to create customized column. But in generalized way, whenever you work with the relational database systems, you have specific data type. So you have predefined data types as well, that most of the systems or the organizations use. And then in certain database systems, you have custom type as well. Okay, so different data types. One thing to note down is different data types available will depend on the database systems that you use. Okay, so let's say you work with MySQL, it may have different database, data types. If you work with Oracle, you may have different data types. If you work with uh, MS SQL Server, then you may have different data types. Right? So data types will depend on the system you're working with, but definitely there will be certain common structure. Let's say you're working with integers, then you'll always have a kind of data type related to int or integer. It's just that the syntax or the how we define or how we represent the data type will differ in certain database systems. Will just type number to represent integer, or numbers in which we may have int uh, or float, all those things, right? So that depends on database systems, but what we need to understand is uh, it all depends on different database, right? So we don't focus on that part. It's just a nomenclature, right, to define the type of data that we are going to store it in relational systems. Then we will understand what is normalization. So if you are already in college, or even if you are working with uh, data systems or database systems, you might be already aware of normalization, right? Uh, you might have idea of different normalizations, like 1NF, 2NF, or 3NF. In this course, we don't need to understand and go deep down to 1NF, 2NF, or 3NF. But what we need is we need to understand the process, right? We need to understand the process of normalizations. How do we normalize data? So the purpose of normalization is you have different tables, right? So in certain cases, some of the systems, we create a table such that there are many duplicated data, right? So we just want to avoid that data redundancy, right? Data redundancy is nothing but duplicates data getting saved in different tables. So we want to avoid data duplication, data redundancy, and enforce certain kind of relationships or integrity as well. So for that purpose, we use normalization. So it is very important term, guys. Normalization is being used by most of the data professionals for schema design. So whenever you're designing tables or database systems, then you always create such a system that different entities, first of all, different entities will be stored in different tables. We don't store or combine two or three different entities in a single table. Okay, so you do that while creating the schema itself, while designing your tables. Okay, so what are the different states? So these are four basic states for data normalization. The first one is we separate it in each entities, right? Like customers or products. So different entities will have its own table. Each and every entity will have its own table. So we don't store customer data plus product data in a single table. No, a customer data will be stored in its own table, which is customer table, and product data will be stored in its own table, which is product table. And the second point to note down is each and every table will have its own column, right? So each entities will be divided into multiple columns, which is basically the properties of that entities. Okay, which is also known as attributes. Okay. The third one is each and every table will have certain unique uh, uh, properties, or we can say unique column, using which you can identify a particular row, right? And that is known as primary key. Primary key may be a single column, a single uh, uh, column, or it may be combination of different column as well, which we also call as composite key whenever it comprises more than one column. So we call it composite key. So but the idea is we should have a unique identity of each and every row, right? So that's the third point. And the fourth is we always try to relate the tables, because we are not storing um, everything into a single table and we disintegrate it, we store it in different tables for each and every entity, right? So there should be a certain way to link those tables so that we can get data from different tables by joining it, or using some kind of relationships, right? So for that purpose, we need a kind of a key or a unit using which you can relate the table. And in this case, in database systems, we call it foreign key. So foreign key is nothing but it's a primary key of the primary table. So let's say we have a customer table. So in this case, we have certain primary key in for that particular customer table. Let's say customer key. Customer key is the primary key for customer table. But if we use the same customer key in other table, so that will be known as foreign key for that particular table. Let's say we are using customer key in the product table, or some other line items, then that will act as a foreign key. Okay, so customer foreign key is nothing but the primary key of some other table. Okay, now we are going to see this sales data. So can you tell me the problem with this sales data? What's the problem with this table? Do you see any issue with this table, sales data table? Yes, order number is not unique. Anything else? Order date. Order date, it's fine, right? It's just on the same date. Multiple items have been ordered by different people or different customers. Customer duplication, yes. Anything else? Do you see this one, product? It's combination of two things, right? Product type as well as price. So it stores two different things, right? And what we learned in normalization, we need to segregate it. We need to store it in different columns, right? The first part is always entity segregation. So in this case, you see that customer data is also in the same table, sales data, and then product is also in the same table. And apart from that, we have this column, right? This product column has product type as well as it contains price as well. So again, we can divide it into two columns. For customer, we are storing name as well as address, right? Name also can further be divided like first name or last name. Address can also be further subdivided into let's say street address, street, and then city, state, pin code, like that. Okay. So how do we normalize it? We're going to see. We already saw it in previous example, right? This is how the data should be stored. So we are going to see the problem with this, and after normalization, how it looks like, how it should look like. Okay, so now we are seeing the normalized tables. So we divided different entities. Now we don't have any data duplication, right? If you see, all the customer related data are getting stored in this customer table. All the product related data items or different names of product type, all those are getting stored in product table. In this case, all the orders are getting stored in this table. And the line item is again a different, which is basically combines primary key of all these just to relate different tables. So we are also creating different relationships so that we can get or query different tables. We can create a relational database systems. So what are the primary keys here? What's the primary key for customer table? What's the primary key for product table? So this is something unique, right? ID. You are able to identify this. You can identify this unique row using this primary key, right? This is called primary key. But the same ID, customer ID, is being used in different table, order table. So in this case, order table has its own primary key, right? Which is order number. But you are also storing customer ID, right? So order number here is the primary key of order table, and customer ID will be foreign key, right? Because customer ID is primary key of customer table. So if the primary key is being used in some other table uh, to create relationships, this is known as foreign key. Okay, now we have stored data, but how do we query it? How do we retrieve the data from database systems, right? There should be some way to retrieve the data from database systems. So SQL provides us the capability to retrieve or extract data from database systems. When we speak about database systems, we are basically dealing with relational database systems. So even for SQL, we have different syntax or different formats to define or to execute the SQL, right? So there are different versions of SQL. So Microsoft, if you're working with the Microsoft tools and technologies, let's say Microsoft SQL Server or Azure SQL Server, then there is a version of SQL which is known as TSQL, Transact SQL. So you will use this syntax provided by TSQL, or there will be certain offerings, right? Not each and every SQL will have the same set of uh, capability. So some of the SQL provide you to create uh, packages. Let's say packages you are able to create in Oracle, but you don't have option to create packages in Sybase or TSQL. But obviously you have option to create stored procedure. So in some or other way, you have you have similar kind of functionalities, but the name might differ. But it all depends. So it all depends on SQL version. So certain technologies or tools will offer you capabilities to access the data in some or the other way, right? So each and every versions of SQL will differ a bit, but the core part will remain the same. The format or the syntax will be very similar to all these different versions of SQL. And whenever you work with PostgreSQL, so there is a different formats or extensions provided by PostgreSQL. And then you have PL/SQL, which is basically the offerings from Oracle. So whenever you work with Oracle database systems, you have PL/SQL, which is nothing but procedural language. And SQL is, you already understand it, it's a structured query language. So we are going to see different SQL statement, right? What are different SQL statement types? So basically, we have three different statement types. One is data definition language, which is DDL. Second one is data control language, DCL. And the third one is data manipulation language, which is DML. Okay, so as the name suggests, right, it is very intuitive, right? Data definition language, that means you are working with definition of tables or database or any objects related, any objects to be saved or created in DB, right? It talks about definition, right? Structure, how do you structure it? The second one, it talks about control. What control? How do you control the already created objects? So in that sense, how do you control it? That means it relates with permissions. What are all the permissions? So you have options to revoke or grant permissions. So all those will come under data control language. And then the final one is data manipulation language, which is now you have the data, you have a structure, you have data. How do you manipulate it? In case even if you don't have data, you have the structure right now, right? You created structure using DDL, but how do you manipulate? How do you insert data? You are not going to change the structure of the tables or the structure of database, right? Schema. So it provides capability to add data or update existing data, right? So which comes under data manipulation language. So we are going to cover all this: data definition language, data control language, and data manipulation language. So we don't need to go deep to all these three, but we need to understand what are different things that we can do as part of when we use SQL. Okay, so these are the different commonly used DDL statements that's being offered in most of the versions of different SQL. And you basically work with these four DDL statements only in most of the cases. So the first one is create, obviously. Whenever you are working with database system, you always need to create objects, right? The first step is to create a new object. So for that purpose, you use this statement create, right? You create a table. So whenever you need to create a table, you use create option, create a statement. So this is the example of create table. So how do you use create a statement? So this is how we define or we create the structure of a table. Let's say we are creating the product table. So this is how we are going to define it, right? This is how we are going to uh, create a table based on the syntax of SQL. So the first part is we have ID, which is basically, and the second part is we need to, the first part is obviously the name, right? Or the identity, which is ID here. The second part that we need to place here is type, data type, right? So in this case, it is integer, which we put it in integer syntax, right? So that's the syntax how you represent integer. And then the third one is you can provide whether this should be, uh, can we store it, can we store null value, or it should be a mandatory column, right? So for that purpose, we have null or not null, whether it's mandatory or it's optional. So it depends on, if you provide it null, then you can store null values. That means it's optional. Even if you don't store price, so it's going to allow you, SQL is going to allow you to execute it. But in case you define it as not null and you are not providing value of name while inserting the data, then it won't allow you to insert the data. So that's basically that's the difference between these two. And then you also have option to define primary key and all those. So this is how you define primary key. Primary key you can also define using constants, but that's not required for this DB or Azure Data Fundamentals. We are going to cover those things in different sessions. Okay, so this is how we create it. And now this is a simple create table. It's basically the same thing. Now we'll talk about DCL statement, which is control language, right? And what do we want to control? We want to control the permissions. So now we already have table. So how do we control the roles? How do we control that which users will have access on which tables, right? And what kind of access they will have. So using these DCL statements, you provide permissions to the user, or you may deny certain permissions to the users or certain tables, right? Or you can completely revoke, you can completely remove a permission. So that's what is known as revoke permission. So in case you want to grant permission to, let's say here in this example, we are granting select, insert, and update permission to user one. On what objects? We are allowing user one to have this select permission, insert permission, and update permission on product table. So this is how we grant permissions or deny permissions. Let's say you want to deny, then you can obviously implement deny as well. But this is how we will write these TCL statements. And then we have DML statements. So DML statement is data manipulation language, right? That means we are going to manipulate the data or existing data, or we are going to add new data to existing structure, right? Let's say tables. So if we don't have any data and you want to insert some data, then obviously you'll use insert. And if you want to retrieve the existing data, then you will use select statement here, which basically reads the rules and then it show you the output on the screen, whether you are using third-party tools, or let's say if you're working with MySQL, you may use Workbench and all, or there should be some way, right? There should be some ID using which you retrieve the data and you should be able to see the output. So you can use different tools for that purpose. And then we are going to use this update and delete, right? So update is basically to update existing data. Let's say we have stored uh, we have inserted certain customer details and we want to update address of the customer, right? So in that case you will be able to update it. So it's, we already see the example here. Let's say we already have a customer, right? Wherein some order ID, we have some order ID. So, and in case we want to update the address of ID1, so we'll use this syntax to update customer table. But if you don't use any filtering, if you don't use where, then it will update this address for all the customers. Right? So it is very important to use where. So filter conditions will always be implemented. Okay. And in case you don't have requirement, obviously you don't implement it. But in most of the scenarios, 99%, you always do this part. You always apply some kind of filter so that you apply the logic only to selected rows. And then finally you have delete. So if you want to delete any existing rows, then you will run a delete query to delete it from the table. Okay, that's I think all. There are certain database objects that is still pending. If you have time, we can continue with database objects, or we can uh, explain this in the next sessions. Do you want me to continue? It won't take more than 15 minutes. Should I continue or next session? Okay. Okay. All right. We'll cover these database objects in the next session. Thank you all. Thanks for joining. In the next session, we are going to cover database objects, and we will see all these different objects that we have. We'll cover different SQL services and capabilities, and then other open source database systems as well. So we'll go it in detail in the next session. Thank you. No, thank you all. We'll see you in the next session. Thanks. Yeah, I'll share the materials with you all. Okay, I'll share the PDF. Thanks, guys. Have a nice day. Enjoy your Sunday.